In today's lesson we're looking at experimental probability. So we're going to jump straight into some examples here, and the first one we're looking at is involving a dice. So we know that there's 6 sides on a dice, and unlike theoretical probability we might not get an even number. So we know the probability in theoretical probability, if we have a dice and we roll it, there's a 1 in 6 chance of that number being a 1. That doesn't always work out like that. So basically, if we think about this, we've conducted an experiment. The outcome here, so this line here, these numbers represent the numbers on the dice. So that we could either roll a 1, 2, 3, 4, 5 or 6. And the frequency represents the number of times that a number 1 was rolled. So if we look at this, we've got number 1 was rolled and it came up 3 times. So first thing we do with a table like this is we need to find out how many trials there were. So all we need to do is add up the number of frequencies we've got. So 3 plus 1 is 4, plus 4 is 8, plus 6 is 14, plus 3 is 17, and 3 is 20. So there were 20 trials. The next question we're asked is how many 3s were rolled. So if we look at the outcome for 3s, and we can see that the frequency of 3s is 4. So if we had 20 rolls, we would have had, in this particular experiment, 3 turned up 4 times. Now the last thing we're asked to do for this particular example is write the relative frequency as a decimal for each of those. So the relative frequency is basically how many times we achieved a particular outcome. So we already spoke about, we've looked at 3s here, so let's just go back and look at 1s. So for 1s we had, what I'm going to do is extend my table and include a relative frequency, put that in shorthand there, section here. So we won't draw that in because it's going to get a bit messy, but anyway, so if we've got relative frequency, so for number 1 was rolled 3 times and there were 20 attempts. So first thing I'm going to do is go through and list all of the relative frequencies as a fraction. So the number 2 was only rolled once, so there's a 1 in 20 chance. There was a 4 in 20 chance of it being a 3, a 6 in 20 chance of it being a 4, a 3 in 20 chance of it being a 5, and a 3 in 20 chance of being a 6. So the only thing we're asked to do here that's a little bit different now is we actually need to give that as a decimal. So pretty simple, we can go 3 divided by 20 is what? 0.15. So if that's 3 there, we can go 0.15 here, 0.15 here. If it's 0.15, then if it's going to be double that, then it's going to be 0.3. And then 4 divided by 20, 0.2. And then 1 divided by 20, 0.05. So there our relative frequency expressed as a decimal. Let's have a look at another example. So not using a dice this time, but we've got this spinner here. So in the spinner we can see that we've got 4 different combinations. So we've got the outcomes being 1, 2, 3 and 4. And when we did our fidget spinner, our spinner here, it was spun 100 times and the frequency was distributed this way. Okay, so that meant out of the 100 spins, 7 of them ended up being a 1. 26 of them ended up being 2, etc. So let's just work through the questions here as they are. How many trials were there? Well, we're told it's 100. And if we added up these frequency numbers here, they would also sum 100 as well. So what's the experimental probability of each outcome? So we could include it as another table, or our other option is we could say the probability of 1 equals the number of favourable outcomes, which was 7, over the number of possible outcomes, which was the 100. So 7 over 100, and we're going to express that as a decimal. Now the probability of it being 2, you can see it's 26. It was 26 rolls and it was out of 100, so our decimal is 0.26. So the probability of it being a 3 was 9 out of 100, so 0.09. And the probability of it being a 4, and you'd want to have your money on number 4 because there was 58 times out of 100, and as a decimal that's going to be 0.58. Okay, so we've now ticked off that we've done the experimental probability of each of those, and we've solved them, just put them in a different form as opposed to the table before, done a fraction and then moved them into a decimal. Now the last thing we're asked to do is what is the sum of the probabilities. So essentially we're going to add our probabilities that we've just found, and if hopefully you've got your thinking caps on and you could actually work out what this would equal. So let's add them up. We've got 0.07 plus 0.26 plus 0.09 plus 0.58, and we end up with 1. And that makes sense, because the probability, when we're talking about probabilities out of 100, well, here was 100 times. So if we added all these together, we end up getting to our 100.